Bismillahirrahmanirrahim. Welcome back, students. You see that we have done this much. I have just introduced that what is work. So that work was F into S. Okay. Now building onto this, we now look at a new situation here. Now suppose there is an object over here. Now suppose this is our object. Okay. And this time instead of a horizontal force pulling this, we have an inclined force over here. Okay, now this inclined force is, let's say this is 10 newtons and this is inclined at 30 degrees over here, and this force has made it move a distance of, let's say, 20 meters. And now we have to see that how much work has been done by this inclined force. Okay, so you guys know that whenever you have the inclined forces, you need to resolve that parallel and perpendicular to the this direction in which this object is going. Okay, so I'll be resolving this. You see that this is going to be resolved like this. So this much is 10 sine 30, if you remember this, and this much is going to be 10 cos 30. Okay, now this is the force which is parallel to the direction of the motion. Okay, so we shall be using this. So this time the work done is going to be 10 cos 30 times this 20. Okay, so this is going to be if you use this is going to be 200 under root 3 over 2. So that is 100 under root 3 joules. This much work has been done. So again, if you have an inclined force, you have to see that this has to be resolved first of all. And you know the rules of resolving the forces. We have to resolve this parallel and perpendicular to the direction of this motion on the parallel and perpendicular to the surface on which this is about to move. Okay, so we can generalize a formula here that if we have an object and this is being moved by an inclined force over here, which is going to be F, and this is inclined at theta, and when you resolve this, so you have this, we don't need this actually, so we need this one, that is F cos theta. So the formula that we initially had for the work, which was work is equal to F into S, now this is going to be evolved into work is equal to F cos theta times the S or the D. Now you can use D or S. Okay, so this is for the cases when you have the inclined forces. Okay, so you people know that we have to resolve these forces. Your mechanics is all about resolving these forces. Okay, from this I have to tell a very important thing over here, that now you see that suppose there is this object over here. Now let's say we are given its mass as well. Okay, now when the mass is given, suppose its mass is 2 kg. So when mass is 2 kg, then there has to be the weight, and then there has to be the normal contact force. Now its weight is going to be 20 newton, and then there is going to be that R as well. Okay, so people normally get confused that since these are also the forces, and for example there was an inclined force over here, let's say that was the same, that 10 newtons, and it was inclined at 30 degrees. Okay, so and let me keep the same distance, which was 20 meters. Now it's the same example, basically this one. I have just added the mass into it. Now why don't we ignore this weight and this R while finding the work done by this this inclined force over here. Okay, so let me give you the reason for that. If you look at the angle that this weight is making with the direction of the force, can you see that this is an angle of 90 degrees. So Do you remember what is cos 90? Yeah, cos 90 is 0. So if a force is perpendicular to the direction of the motion, like we have the weight and we have this normal contact force, then the work done by that force will always be 0, because cos 90 is 0. So please remember that a force which is perpendicular to the direction of the motion, the work done by that force is always 0. So therefore we have to ignore this this weight as long as this is moving horizontally. Okay, I hope you got the point that the work done by the weight in this case, or this R in this case, is going to be 0, because these two forces, these are at right angle with the direction of the motion. Our object is going in this direction. Okay, so this is the second thing, like our formula from F into S has gone into F cos theta into D. Obviously, if your force is not an inclined force, you will keep on using this formula. Okay, and if this is inclined, then you will have to use the component of the force which is in the direction of the motion. Okay, now I'll be introducing energy in the next video. Okay, so please stay tuned.